let's check if it's recording. Cool. Hey guys, this is David. I guess this will be today's problem. It's bargaining. It's a nice little, it was a little bit of a challenge for me. Took me quite a bit of time. So, I guess we'll start. Right now, Sasha and Vova can't come to an agreement. So Sasha gives this number, blah, 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 blah. And Vova can remove a consecutive substring. Consecutive meaning the numbers have to be connected, and a substring meaning like it's within the string, of course. And so basically she chooses one, and then when you remove it, the result is this answer. So let's say that you take out this substring. You have 12 on the left and 1 on the right. You combine it, and you'll get 1, 2, 1. Now what Sasha wants to do is she wants to compute the sum of every possible removal that Vova can make. So Vova can't remove all the digits. That's another thing to keep in mind. Now, you want to, since this number is going to be pretty big, you want to print it from 10 to the 9th plus 7. Another thing is n is ridiculously huge, so we can't store it as a number or integer, long, big integer. Can you store a big integer? I don't know what Java's big integer. Like how big can it be? Yeah. So for this example, the possible numbers given when you remove 1, you'll have 07. When you remove 0, you have 17. When you remove 7, you'll have 10. When you remove this first part, you'll have 7. When you remove this part, you'll have 1. And when you remove everything, you have 0. Well, you can't really remove everything, but well, if you do remove everything, it's 0. So we don't need to calculate it. So on to the algorithm. Let me check if it's full thickness. Whoa, weird. Anyways, so let's start with I guess an example. So let's see. How should I explain this? Okay. So whoa. What the heck? Huh, that is weird. There we go. Okay. I don't know what happened there. So we'll start with a nice little easy example, 1, 2, 3, 4, 5, 6. And so I guess one thing to approach this is, I guess we'll see what would happen if you just remove the first and last index. Something easy, because you don't have, this doesn't have a left and this doesn't have a right. Well, what happened is you would have 2, 3, 4, 5, and 6. That would be the first one. So you would have to add every possible one. So it would be 2 plus 23 plus 2, 3, 4, on and on and on. And then for this one, it would be 5 plus 45 plus 3, 4, 5. Let me just make sure my code makes sense. Cool. And so I guess the strategy would be to construct a prefix sum, or a prefix, not necessarily sum, because what you want to calculate is this property. I don't necessarily know how to say it, but it's essentially just taking out everything to the right of it. So I guess that's how it's made, because you just add the number to the previous prefix. Kind of like, if you don't know what a prefix sum is, you basically extend your answer from one prefix. So prefix I would be an extension of the one before, which is pretty cool. Now, how this prefix sum will work is you'll want to have it as, I guess, okay, so we have this number, so we'll call it x, plus the one before, so prefix I minus 1, and then you want to multiply it by 10 so you can leave room for it. Same idea with the suffix, except it's a little bit reversed. So you want to have it like suffix I. If you don't know what a suffix is, it's just basically the opposite. So you have 6, 56, and then dot dot dot, and then you go to 1, 2, 3, 4, 5, 6 here. And the number would be +1. Remember +1 because you're looking forward. Plus x, which is this number or whatever index you're at. This will be multiplied by 10. So, yay! And you want to go backwards for suffix because suffixes usually go backwards, and also because the 10 will be hard to calculate. Yeah. So, yeah, those are what you get for the first and last ones, but how do you calculate the middle ones where you have the left and right? Well, that's a little bit, it's actually kind of easy. It may seem a little crazy because you have to calculate every single possible thing, but you really only need to calculate in one direction so that you don't double count. Or what I mean double count is you'll count the same number twice. So we'll start with 2, right? What happens when you remove 2? Well, you have the left side plus the right side, and you'll have 1, 3, 4, 5, 6. What happens if you remove these 2? Well, you have 1, 4, 5, 6. And what I mean, the reason why I'm keeping 2 is, let's just say, like, this prepares you for a for loop. So let's say I is 2, or I is in this index. You keep on doing this, and you don't remove all the way here because it's already been calculated by the prefix sum, and yeah, you don't want to double count. So you keep on going, and well, you'll notice that there's like a nice little pattern. So it'll be, for this would be 1, so 1 would be, well, 1 times 10 to the whatever number is left on the right side. So I guess 4 times 10 to the third times 10 to the second. Remember, this is going to be 3 digits because you take out these 2. It's going to be 2 when you take out these 3, and then it's going to be 1 when you take out these 4. So 10 plus whatever's on the right side. Right. I'll break it down actually. So what will happen is this is merely 10 times 1, that would be the right side, 10 to the 4 because there's 4 on the right side of the index, plus whatever's on the right side of the index, so it's 3, 4, 5, 6. This would be 10 to the third because there's 3 digits on the right, times 1, which is the left digit, plus whatever's on the right, so 4, 5, 6. Now, if you couldn't follow that, yeah, if you couldn't follow that, it's basically you take this times how many digits to the right plus what is to the right. And then you'll notice if you break this apart, you can leave these, combine these, and you have 1 times 10 to the third plus 10 to the fourth. It's not in the right direction, but like you'll notice if you add these, you'll get the same answer, similar to how a plus a equals 2a. It's just like math, basic algebra. If you add these, because they all have a factor of 1, you can combine these 2 together, and whatever the suffix is. Actually, wait, no, the suffix sum. Right. Suffix sum. Yes. Whatever the sum of these numbers are. because you can just group all the suffixes together. So I might have alluded to it, but what you'll need for this algorithm is a prefix, a suffix, suffix sum, a prefix sum. This is to calculate the required number of numbers, or the sum of the with taking the first index, and the suffix sum will also give you the last index as well. And you want to give a tens array, which tens to the I will equal to 10 to the I. This will only help you. This is just to help you with tens sum. And that is, this tens sum is basically used for this. It's the sum of, when you're given tens sum, I, it's basically 10 to the I dot dot dot. This is all adding plus 10 to the first, just like over here. So connecting everything together, I know everything was a little bit of a mess. So what you do is, on the first, to calculate the problem, you'll take the first one and the last one, calculate their total prefix sum. This will give you n minus 2. It's n minus 2 because VOVA can't remove every single number, so the most they can remove is about this much. Prefix sum plus suffix sum. That will also give you from to the left side. So that'll be 1, because the most they can remove is this amount. And yeah, so that's the first two numbers, and then the middle numbers will be calculated through a for loop from I equals to 2 all the way to n minus 2, because you can't, if you calculate the n's ones, because we already calculated it. Oh, I can't scroll down. No. Oh, okay. Cool. We calculate through a for loop, and the basic equation is you add from over here. So you'll have whatever's on the left, like I said earlier. So the whatever's on the left would be the prefix. You want to take it I minus 1 because it's to the left of it, multiplied by the tens sum of I minus 1. Oh, sorry. You want to have the tens sum of how many numbers on the right side of the number. So that would be n minus I minus 1, because n minus 1 is the total. Well, you take out 1 because you can't remove every single number, and I, yeah, it just gives you the total amount on the right side. So that, not ending actually, plus the suffix sum. Remember from earlier, suffix sum is all the numbers summed up to the right. So because we've divided from this plus this, suffix sum of I plus 1, because you want to go forward. Can erase it? Okay. And yeah, you'll want to add every single, this will give you the middle numbers, and you want to add every single one to an answer, and then that'll be it. So let's look at the code. So this will be in C++, so if you're a Java nerd, I'm sorry. So we put this in a string because the n is a little bit too big. Let's just check the time, because I did record for a while. Ooh, 15 minutes, so quite a bit. Hopefully you'll pay attention. But you put it into a string because the n is ridiculously large. It's 10 to the 5th, which is pretty crazy. This is just some base cases. So n equals 1, that means Vova can't remove anything because Vova is not allowed to remove everything. If that makes sense. Like if I only had one number, Vova can't do anything because she can't remove the whole integer. So that gives you 0. Same thing with this. If you only have two numbers, you can either take out this number or take out the first number. And a cool, neat little trick, if you don't understand what this is, you basically, for any string and you want to parse the int, in Java it's parse int and whatever jazz. But in C++, you just put the char. So it's basically in C++, every string is just a char array, so you can directly grab it. Unlike in Java, you have to do like s.char@, which is kind of cringe, but whatever. You can just basically get the char you want and then subtract it by 0, the character 0, and you'll get whatever parsed unit you want. So that's pretty cool. So this part is to simply set up tens, or some tens, set some tens. You don't really use tens, but it's helpful to keep track. Now, this is just this, or you don't really use tens this array, but use some tens more. It's just how to keep track. I can basically do the same thing without, I can basically do the same thing without the tens array, but it'll be hard to track. You'll notice these mul mods. Remember in the problem statement that you want to be modular. I think that's the max int number. So you want to be modulus of that. That's the basic idea. Wrong one. You want to be modulus of that. So whatever calculation you have to do, whether it's adding or multiplying, multiply it, and then you have to mod it. This mod's right here, or this is the same thing as that. But Java is a little different. I don't know how to calculate 10 to the 9 plus 7 on there, but that's what you do in C++. Okay, so yeah, so sums, and then this is setups to prefix and suffix. So this gives you the first integer, this gives you the last index. You add it. This would be just, I guess we'll go back to the drawing board here. Please don't lag, please don't lag. Okay, this goes back here. How to calculate prefix, right here. Oh no. Prefix is x, which is this right here, plus this times 10. And add mod, prefix sum. Yeah. So this is just takes the sum of the prefix. So it's kind of a prefix. It's helpful for prefix. Yeah. And so same idea here. I have this p because it's a little bit hard to calculate tens and like 10 could get really big when you start from the beginning. That's why I go backwards. And this will be the first index, all the possibilities when you remove the first index and all of its consecutive substrings. Same thing here, but this will be the last index. Yeah. And so, wait. Oh, I mixed this up. First. My bad. And then these are all the middle numbers. You'll notice that it's not to n because we've already done the first and last index. And same equation here. This is just simply the prefix times the sum of tens plus the suffix at the end. And you'll just simply add that to and don't worry if these mods here, you just remember modulus it. I don't know, I think it's a good strategy. Some people use mint, modular int, which is this complicated class. I still don't really understand it, but it's supposed to be useful. I don't really use it, but I mean, I'll probably have to use it when I do more gold pieces or gold competitions and such. I'm lagging like crazy, but yeah, that's how you get it. It may seem like magic, but once you realize it goes through literally every single possible. Wow, there's an error. Great. Once you realize it goes through every single possibility, it's actually quite nice. Binary operator. Oh, because I changed this to this. Oh, that's why. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? I hope that works. I'm lagging so much, wow. But I think that's the right number. Yep. I'm actually quite nervous about this. I don't want to make a mistake. 29 plus 7. Let me just make sure it compiles. Oh, I'm just going to submit it. Compile. Question mark. But it may seem like magic that it's working, but once you realize it literally goes through every single one in a pretty efficient manner by combining, like right here in the combining these into just one nice equation. It's pretty nice, and what it seems like it's like an O of n, like the brute force way would be to go through every single possible way, but what seems like it's going to take really long gets cut to O of n squared, or O of n, which is really nice. I have to go to documents, blah blah blah. So many garbage. I don't really care if people see it, but CP, codeforces, and C bargain. And hopefully this will get the accepted. I think it will. Oh, wrong answer on test 1. I must have put something weird. I figured out the issue. Turns out I didn't put n-1. Remember, this is a reminder. When you're doing suffixes, you want to start with n-1 instead of 0. And poop. I just made that rookie mistake. So let me just check it one more time. The issue was 107, I believe. 107 and should equal 42. Cool. We'll just see the satisfying 22C. That was annoying. It was just one small bug. It's gonna happen a lot, but I'm glad I found it. And it's 12:52. Why is it stopping on test 2? What the fuck? Okay. Well, that's it, everybody. That was Bargain, and it's 1 o'clock. Good night.